Hey folks, so in this video, what I want to do is run a trace by hand of how BFS works. Note that before you go through this video, you should make sure you have a good idea of what the rules are, or maybe even have the rules/algorithm on a piece of paper somewhere to reference. All right, so here's my sample graph, and I have 5 different nodes and then some edges thrown in. So let's try doing a BFS. So I'm going to try doing basically my BFS starting out of this node over here. So this is node 0. So how do I do this? So initially, right, what I would do is this. I would say to start with, right, this is going to be my algorithm trace here, like what I would put on the piece of paper. You can see that on the left-hand side, I basically have a description of a problem, right? So I'm going to follow along here with this idea of, run the BFS to find the shortest paths between 0 and every other node, right? That's what I'm going to do, right? I'm kind of just following along with what might be kind of look like an exercise. So initially, I'm going to start, and what I have to say is, I'm going to initially basically have to have 0 as marked, right? So marked of 0. So I'll even put it on the graph here, and also that I have a Q where that Q has in it the number 0. All right, so this is how I start. And we'll draw maybe a slightly better Q for you guys. Q, there we go. So this is how I start, right? Marked of 0, Q of 0. Okay, so what do I do after this? Well, I have to go into that loop, right? So there's this loop basically that'll run inside BFS until that Q is depleted. So let's see what happens. So over here, what I'm going to do is I'm going to write that we're going to go loop of 1. And then the first step in that loop is basically to pick something out, right? Pick out a node. Let's go ahead and call it just like V. So V in this case equals 0, right? And you have to kind of remember that Q now is empty, right? It's empty. So now that I'm looking at V, what happens? Well, I look at my graph and I see who are the neighbors. 1 is the neighbor, 1's unmarked. So what I want to do is I want to mark it and then add it to the Q. So over here, I'm going to mark 1. This equals true. Should be equal to true over here. There should be brackets there like an array. And then Q now all of a sudden has been updated and now has the number 1 in it. Okay, so that's the first iteration of the loop, right? I took out 0, I explored it, found its neighbors, they were unmarked, there was only one neighbor and that neighbor wasn't marked, mark it, add to the queue, right? So it's like I'm moving out. So this is kind of this is my layer is 0, right? Is over here. Right, now I'm moving out, this is now layer 1, right? The things that are of length 1 from the origin. And so I got to repeat, right? Because my loop isn't, because my queue isn't empty yet, right? So I got to repeat. So now let's go on to loop iteration 2. So loop 2. In this case, V is equal to 1. So V is 1, so we're going to go and see what is next to 1. 1 has 4 things next to it. So it has 0, 2, 3, and 4. Okay, so now you can picture, right, we're looping through its neighbors. The thing is, though, okay, I mean 0 is already marked, I'm not going to worry about. Then 2, 3, 4, those aren't marked, right? So maybe I want to think about looking at those, okay? So what I'm going to do here is basically mark them, right? And I'm saying in my assumption on the left-hand side that edges are discovered in the order that they are numbered. So we're going to basically say that 2 is going to be the first thing that is marked. So we're marking number 2. That's true. And then we'll also do marked of 3 and then marked of 4. Note that the order that I put these lines in is important, right? So these should match the order in which the algorithm is going to explore the nodes that are next to our origin, right? Those have to line up. So let's say I've marked my 3 new things. Excuse me, my 2 new things. I think I threw in one thing by mistake. 3 shouldn't be in there, right? I used to have an edge there and I deleted it. So 2 and 4, right, are the neighbors of 1 that are there. So now, right, I need to update my queue, right? I need to update my queue. I get to add 2 more things. So basically my queue gets updated to look like this. 2 and then 4. And then like I said a second ago, the order does matter, right? So the first thing I saw in this algorithm was 2, and then I saw 4, right? Given that I was going by basically the order that they were connected to. And somehow in my queue, right, you have to remember it should be my front, right? 2 is the first thing, so 2 should be my front. So yeah, so I have basically this, right? And I can kind of draw this in a little bit, right? So here, right, I'm basically saying that my L2 now, right, is basically kind of these things over here, right? These are the nodes that are at this certain distance. And I do need to be a little bit careful here. In this example, my layers over here in the picture are going to match up with my loop iterations, but that may not always be the case, right? So just FYI. All right, so I've gone through my loop, right? So I've explored a little bit more. I've added 2 new things. I need to continue. So then I'll go over here and do my loop. It should be loop 3, I guess. Loop 3. And my loop 3, well, in this case, my V is going to be equal to 2, right? Because that's the thing in front. So that's what I'm going to pick out. Basically, 2 is in front, and 4 is still left in there. So I'm looking at 2. Well, 2, right, And I really should put my diagram over here, right? 1 is marked, 4 is marked, 2 is marked. These are all you can see down there, right? We already marked them at some point. Well, if I'm looking at 2, the problem with 2 is all of its neighbors, right, 1 and 4 are already marked, so I don't really have anything to do. So what I'll actually do is do nothing, right? I'll basically just update Q. So Q is now going to just be the number 4, okay? All right, so nothing happened there. Now we go forward, right, into loop 4. And for loop 4, now V becomes equal to 4. Okay, what's next to 4? Well, it's 1, 2, and 3. 1 and 2 are already marked, nothing to do. 3 isn't marked. Oh, hey, I can take care of that one, right? So I'll do a marked on 3. And then I'll update my Q, right? My Q now looks like just having 3 inside of it. Okay, and so then I kind of step out again, right? I do another loop, loop 5. In this case, V equals 3. 3 doesn't have any neighbors that are unmarked, so there's nothing to do. So I just don't add anything to the queue. The queue is empty. And so then I complete, right? And it just exits out. I'm done going through this. And I have kind of my 4th layer there, right? So this one over here, or it should be, let's see. So this is, well, I'll call this L3 over here, right? L3. So basically, right, you can see that the stuff in L0 is the stuff that I can get to in basically 0 edges. Stuff in L1 is the stuff I can get to in 1 edge. And then L2 is the stuff I can get to in 2 edges, right? A little bit more work. And then the stuff in L3 is that just that one node that requires me to get there in 3 steps. So basically, I have the different distances there, right, based on how long it takes me to get to there from the origin, right? So we're just kind of creeping out one layer at a time. All right, so that's what I got for you guys in this video. Hopefully this makes sense. I would recommend you try, running this on paper, right? As well as, right, we're going to go through a little bit of a visualization in a couple of videos to get you even some more concept for how this works, right? For now, though, just visualize that you're spreading outwards from the middle, and you're spreading outwards by kind of keeping this queue maintained on the stuff that you need to do, right? And you're always just following your queue, right? So that you process things in the order that you see. All right, so I'll see you guys in the next video. We'll talk about the source code for BFS in a little bit more detail.